In this episode from Coding Adventures, we're gonna implement two-sum coding puzzle from LeetCode. So let's get started! Alright, so we're looking here at this two-sum coding puzzle from LeetCode, and this is an easy puzzle, and let's read it before we start implementing it. So basically we are given an array of integers, and it's like this one actually, and we need to basically to identify in this array two numbers that adds up to a certain number, and then return the indices of the two numbers. So for instance, in this array that they provide as an example here on LeetCode, if we provide to our code this array as input, and we attempt to, for instance, to find the number, which numbers add to 9, it's obviously the first one and the second one, well, the output should be 0 and 1, this being the indices of the two numbers in the array. So let's get into the code editor here at LeetCode, and I put it in a separate page just to be a little bit more visible on the screen. And we are provided with this stub for the function that we need to write. Since we are on a coding channel for beginners, let me rewrite this function a little bit, which basically means the same, but it's a more familiar form to more people. So we need to implement function two-sum, and let me change also the coding convention to have the curly brackets on different lines. And we need to implement this function. And let's take again from the example this array, just to have it in front of us. And for instance, also target 9. So let's have it here like an example. And we're gonna go and put it in the code. We can write it here above the function. So how can we implement this function? Well, let's get first to the whiteboard and write this array here really quickly on the whiteboard. So for instance, we are provided with the array 2, 7, 11, and 15. Let's say this is an array actually of numbers. Can be even bigger, but you know, this array should be enough for just implementing our algorithm. And this is an array of numbers. Of course, this is the first number, 0. This is the second number, 1. This is the 2 and 3. These are the indices of the numbers inside the array. And we need to identify which elements adds up to a certain value, or 9 in our case. So obviously we can see this is the first two numbers, but how do we attempt to do this? How can we create the algorithm? And just to, you know, maybe I should copy the array here a little bit down. I think it will make the explanation a little bit easier. So let me copy really quickly the array here. It's the same array that we have also on the screen. And put here really quickly the numbers inside the array. So we have the two arrays. So the solution that we're gonna attempt to implement in order to identify which numbers add to 9 will be the following one. We're gonna iterate, let's say using a number I, on all the elements in the array, right? So we take, for instance, number 2, and then we move to number 7, and then we move to number 11, and then we move to number 15, and so on and so forth. But for each I, we'll also iterate again on the array. And I just draw it second time just to be a little bit easier. So let's say for each I, iterate again. We can even use a different counter, let's say j. So for instance, we pick the first number 2, and then we iterate again, and we iterate over 2, over 7. Actually, we should not iterate over 2 again, because it should be different number, right? So we start to the number next coming after the current number. So we'll iterate over 7, over 11, over 15, and so on. So when two numbers will add up, we're gonna return them. So for instance, in this case, we'll match on the first position. So this is the position 0, and this is the position 1 here. So we'll return immediately 0 and 1. But let's suppose this wasn't 2 here. This was a totally different number. Let's say 2 comes here towards the end, and yeah, let's say 2 comes to the end here. So this being a totally different number, when we iterate over the first one, let's say this is 12, this won't match this one. This plus 12 plus, and this is 12. 12 plus 7 is not 9. 12 plus 11 is not 9, and so on and so forth. And won't match any number basically. So in the moment we're gonna reach number 2 at the end here on the first iteration will be 2 plus 7, and then will be 9, and we'll match it. And if 7 is not on this position but in the middle, we'll return totally different indices. So here on paper I actually drew 2 arrays, but it's the same array. We don't have to copy it and clone the array. We just iterate over the same array, but I just draw it twice just to be a little bit easier to understand. Alright, so let's get started. We are here inside the function, and let's create our first for loop. For let I equal basically from 0, I is less than nums.length, and then I++. Alright, so the first iteration on the array is complete. And now, as we said, for each element of the array, we have to iterate again on the array. Let's use the j variable this time. This time we won't start at 0, we won't start at 1, but we'll actually start on I+1 because we anyway the elements before they are checked in a different iteration, so we start at I+1, and we cannot start at I because we don't want to add them the same, so it needs to be different numbers. And then again j similar conditions, less than length, nums.length, and j++ here. Alright, so both I and j variables will be used to iterate over the same array. So at this point, all we have to do is to write here a simple condition to check if the two numbers added together match the target, which is provided here. So let's write this condition, shall we? So let's say if nums of I, and we add it with nums of j, if this is equal to target, well, then this is the case that we are looking for. So we just have to return the numbers, but actually not the numbers inside the array, but their indices, which are very easy to return. They are I and j. So we return I and j. All right. So now the problem, if we read back again here, and if we scroll down, says only one valid answer exists. As you can imagine, what is happening if, let's say, we iterate and we cannot return anything. Those are exceptions, we can return different things, but this is a very simple problem, and we are guaranteed that one answer exists. Well, we can return, we can just leave it like that, or we can return an empty array here. It doesn't matter. Probably this particular code won't be reached if we run this problem on LeetCode. So, well, I think we're in good shape. Shall we run it? Okay, let's try it. Let me zoom out a little bit because I zoomed in so we can better see the code. So this is our code, and let's run it. Let's run the code. And ta-da! It says here we are accepted. So our code is excellent. It runs. And as you can see, this is they try to test our code using this particular array, and output is 0, 1, exactly as expected. So we're in good shape. I think we implemented this one. I cannot zoom in now. We have this toolbar on the bottom. Oh, I can collapse it. Very good. But I think we can do even better. And if we are even reading here on LeetCode, let me check here a little bit. Yep, towards the bottom. Yeah, follow up. Can you come up with an algorithm that is less than O(n) squared time complexity? Now, we won't go into O(n) formulas here and time and space complexities. I recommend you to do a subscription to LeetCode. They'll explain all of that to you. This is just a simple channel for beginners, but I think we can do even better. So, what is the problem, and why they suggest us, or they ask us to come up with a better algorithm? Supposedly this is not that fast, which indeed is not that fast. So let's switch to our implementation, and I'm gonna show you. Notice these fors. They are two nested fors. Each time you see nested fors, you should be very cautious. Now, for this particular array, it's a small array, or even for a bigger one, 2 nested fors will be fine. But nested fors are very time consuming. Basically, for these numbers, let's say we have 100 numbers here. So basically 100 again here. So basically we'll iterate 100 times 100, 10,000 times over the array. These numbers add so quickly, and 10,000 times is nothing, but imagine here we have 1 million numbers, and then you'll have 1 million times 1 million. So it basically grows very, very quickly, and so the algorithm will degrade more and more with bigger data sets. Therefore, we said that we may come up with a better solution, and indeed we can come up with a better solution. Let's keep ours. So let's comment ours. Let's keep it here in the code. And let me just write again the prototype of the function like that. All right. So the second solution that I'm going to present to you, it's similar to this one, but instead of iterate it a second time through the array in order to find out this if these two numbers adds up, we'll iterate just once, and basically we're gonna keep in a different structure all the numbers that we left behind. Yeah, I think we can say like that, or let's say the complement of them. We're gonna use a dictionary. Which is in JavaScript, it's a map. So you basically you can instantiate a map like this one. Let map equal new map, right? So what is a map and why is different than an array? Well, the big difference, and that we're gonna leverage in this particular case, is the speed. So let's say we have here a map, which again you can look at it as an array, but or like a dictionary, more precisely. Let's say it's a map. Some people call this hash table. Let's also use the term dictionary. All right. So exactly like in a dictionary, where you basically look up people based on, or you look up phone numbers based on people name. Here you have also the same concept. You have a column that is called a key, and you have one called value. So let's say in this particular key, you have some numbers as keys. And for values, you can put whatever. You can put person names, addresses, cities. Let's say there are other numbers here. 300, 500. The thing is, if we're gonna ask this dictionary with a syntax such as get me the number from the key 3, so basically which is this one will respond immediately with, let's say this is 300, with 300. And you may say, well, we can implement this very easily with an array, but there is a difference. This structure has a special implementation that maybe, you know what, maybe we're gonna cover it in a future video, but it won't scan the entries one by one. Like, for instance, when you are looking in your address book, and young people probably don't remember big address books or big books, but in order to locate a person, you don't start with the first page and you just look name by name until you locate the phone number. There is a certain algorithm that you do in order to locate the number quicker. And the same dictionary here has a certain algorithm inside. So basically this kind of operation to obtain a particular value based on a key is very fast. Much faster than scanning an array. So this is the trick. So we're gonna first use the array. We still have to scan our original array. At the end of the day, we receive the data in an array, so we have to take each element one by one. There is no way around this one. But we're gonna try to get around on the scanning array, again, the second array. And let me also open a reference to the map here. And I think map MDN. Mozilla Foundation should have a very good documentation, reference documentation about map. All right. So exactly like we wrote. So to put items, we use set, and to delete, and to get an item, we use get. Exactly like we said. So this is exactly what we're gonna do. So let's try to attempt to this one. First, let's iterate to the array like we did first time. So we'll have a for let I equal 0, I less than nums.length, I plus plus. All right, the first for is here and we have to do with it. Now, look what I'm gonna do. At the end of the day, we need to basically check if sum of two numbers is equal to the target, to 9, right? So in this dictionary, let's plan to skip the complementary of the numbers that we just scanned. So basically a complementary, what it is, it's the target value minus the current value. So imagine here, and I'm switching back. So imagine here we are scanning our array, and at one point we encounter number, let's say we encounter number 2, right, inside the array. If in the dictionary we'll be able to ask that our dictionary, well, do you have a complement of 2 inside? And if the dictionary will find number 7 inside, well, in that particular case, we can, for which we store the position, in that particular case, we know exactly that that these two numbers add to 9. So each time we scan a number, let's say we start with 2, immediately we put inside the dictionary the complement, like 9. Let's say we scan a 7, we put inside the complementary position like 2. We scan an 11, well, this one is not a very good case. We'll see what we're gonna put inside. Actually, it will be a negative number, right? So we put the complements, and then by doing this, when we scan the array and doing quick lookups, we should be able to figure out this very easily. But hopefully it will make more sense in the moment we're gonna write the code. So as we said, as we scan the numbers, we also calculate the complement and we store the complement inside the dictionary. So let's calculate the complement here really quickly, for the complement for I basically. Let's say let complement, which is target minus I, right? So complement of 2 will be 7 because numbers, complement means what number added to 2 will give us 9. So it's a 9, right? It's a 7, right? So we can calculate this complement, and well, now we can ask the dictionary at this point. Let's say the complement position. Let's ask the dictionary, what is the position of a complement? This one particular. Let get complement. Let's say this one was added at this point in a different iteration of I. So we ask the dictionary for this one, right? So the dictionary, let's check back the reference. What is happening if we ask for get? I think we get undefined. For sure you'll get undefined. You can check the reference yourself. So if the dictionary doesn't have the number inside the dictionary, so basically if the complement position that we try to retrieve from the dictionary, it's if basically this one, let's say we found it's different than undefined, so well, that means that we found we found the number in the dictionary, so we return it immediately together with the current number, because these together they add up to the target. So this is perfect. However, if we cannot find it, we'll just put it in the dictionary, map set, and now we put as a key the actual number. This is the trick. We'll put as a key the actual numbers. So basically nums of I, and as a value we put the position. That's why we ask the dictionary here there is any complement for this number. So for instance for number 2, and if it's a complement, it will return us the position. So as the dictionary builds up, inside the dictionary we should add here 9, here a 2, here a 9 minus 11, a minus 2, here a minus whatever. In our particular case, the dictionary won't fill up to those positions because these two numbers will be identified immediately. But you know what? Let's try the code. So let me zoom out again and run it. Wrong answer. Wow! We have an error in the code. So it's good that we got this wrong answer. Well, if you get a wrong answer on LeetCode, what I want to say is that you can take this function in a separate environment where you can better debug it, right? But in this particular case, I think I spotted the error. The complement is basically the target minus nums of I. I'm not subtracting the indices, but actually the number. So let's run it this time. All right, and our solution is accepted now. So let's quickly inspect the two solutions. So this is the trivial solution, the one that we have here on the bottom. Let's actually maximize this. This is the trivial solution. It just scans the array twice, which in majority of problems that you encounter with not that big data, you know, doing nested loops is fine. But if you are working with big sets of data, this becomes a problem, and you have to look into a more optimum algorithm or using better data structures. In this particular case, it's not the algorithm, but it's a better data structure utilized here, the map. So there is only one single for loop and then a very quick map get, which is much faster than array lookup. So here you have it. You have two implementations for a very simple problem from LeetCode. We're gonna try to do more of these problems in the futures. Until next time, happy coding!